Hello and welcome to a new video. This is for Math UC Zeta. We are on lesson 21, which we are going to talk about decimal remainders. Now, because I am a little bit overexcited about math in general, I've kind of already done some of these types of problems before in our earlier lessons about decimals. So keep that in mind, that some of this may already seem familiar to you. Basically, this lesson is supposed to deal with the idea of what if as we're dividing, what if it doesn't come out evenly quickly, or it doesn't come out evenly nicely, or evenly at all. I probably didn't need to list those three things, but the book, the Zeta book basically says there's four kind of ways that we can approach this. So we're going to do two problems based on each way. And in this case, it's going to be important for us to read the instructions as we go, because they're going to help us, at least some of the time, be able to stop sooner than if we just kept dividing. Because basically, any division problem we do, we can keep adding zeros at the end of our dividend, which is the thing inside. We can keep adding zeros and we can keep dividing as long as it makes sense to keep dividing until it comes out evenly. The problem is that not everything actually comes out evenly. There are actually lots of things that when we divide end up going on forever. So what we want to be able to do is come up with ways to deal with that. So the first way to deal with that is to just say, well, let's just add zeros and then hope it comes out even. And so on these first two, that should happen to us, that we may need to add some zeros, but eventually this should end up where we'll divide and be able to stop dividing. So let's take a look at how this works. Okay, so I want to put 5 into 0.68. Since it's a 5 and not a decimal, I don't need to move any decimals. 5 doesn't go into 0, so I can put 0 up here. And then I can put my decimal place right here to show that that's where my decimal is going to be. And I say, how many times does 5 go into 6? It goes 1 time. And so then we subtract 5 underneath. 6 minus 5 is 1. And then we're going to drop down our 8. Now we say, how many times does 5 go into 18? So that's 3 times, because 5 times 3 is 15, which is less than 18. So I put 3 up here, and I subtract 15. So here's the situation. We are out of numbers, but we have this 3 down here. At some point in math, right, what we did is we just wrote R3 for a remainder. But basically this idea of decimals means that, you know what, we can put a 0 here, and we can drop a 0 down, and we can keep dividing it until this comes out evenly. And since we're dividing by 5 should end up always coming out evenly, because 5s are nice like that. So 5 into 30 happens 6 times, and then we subtract 30. And see, this did work out evenly. We only actually needed to add 1 0. There maybe wasn't a way to know for sure how many zeros we might need to add. We just had to kind of take it one step at a time and see what happened. So 0.68 divided by 5 is 0.136. And remember, that's just saying that there are, it's kind of depending on how you want to say this, like we could say there are 5 0.136s inside of 0.68. That would be one way of saying it, that's kind of the situation going on here. Let's look at this next one. We're dividing 0.8 into 3.975, but I don't want to divide by 0.8. We always want to divide by a whole number, not a decimal. So I'm going to move this and make this be a regular 8, and so that means I need to also move the one underneath. I don't like dividing with those little things there. I used to not care, but now I care for some reason. So I'm going to rewrite it. 8 goes into 39.75 is now what we're trying to figure out. I also want to throw out there, and this is true for like the Math UC workbook or for anything really in math, you may want to do this on a separate sheet of paper so that you have plenty of room, because I, as a teacher making worksheets and things like that, I can try really hard to make there be plenty of room, but it's so easy to just fail at that, because you may need more room than I would ever expect you to need. So if you do it on a separate piece of paper, that's great. If you're turning in your work to a teacher or having a parent look over it, you want to keep that work so they can see it. So if you get it wrong, they can help you figure out, hey, where did you go wrong? Never throw your work away. Never erase your work. always keep it with the problems, okay? Now let's divide. 8 does not go into 3, but 8 goes into 39, and it does that 4 times. So that's 7 left over, and we're going to drop down that next number, which is a 7. 8 goes into 77. I got confused for a second. It goes in 9 times, because I was thinking 72, but I was thinking 12. 8 times 12 is not 72. 8 times 9 is 72. So we get a 5 left over, and we drop down our 5. 8 goes into 55. It almost is 7, which would be 56, but not quite. So this should be a 6. So then we would do 8 times 6 is 48. And then we have our 0 here that we added. So we're going to add zeros until this works out to come out evenly. So 8 goes into 78 times, because 8 times 8 is 64. And then we drop our 0 down. 8 goes into 60. That would be 56. So 7 times. And definitely, I haven't looked really closely at the problems in the workbook, so I don't know how often on these you have to go this far out. Basically, these are kind of hard to create problems that work out the way you want them to and are still interesting, which is a thing I really like to be able to do. 8 into 40 goes in 5 times, and so we've finally gotten this to work out evenly, because now we don't have there's no point in adding more zeros because we already have a 0 down there. So this ended up being 4.96875. Now this is just one of the ways we can approach dividing when it doesn't divide evenly quickly, where we can add zeros until it comes out even. But there's a couple problems with that. One just happened to us on B here. We divided a lot. Do we really need that many decimal places? We could argue yes or no on that. But wouldn't it be nice if we were like, okay, this is how many decimals I need for whatever I'm doing with this number. So like, for instance, if we have money, right, we only need 2 decimals if we're dealing with money. So wouldn't it be nice if we could just say, okay, I'm going to get just 2 decimals. Well, there is an issue with that. And so our next section says, divide to the thousandths place and round to the nearest hundredth. So the idea here is that, let's say we are talking about money. We divide these numbers and we want to round to the nearest cent to be accurate. Well, if you're going to round to 2 decimal places, you need the 3rd decimal place to help you decide whether that rounds up or down. So just a quick reminder on how rounding works. We look at the next place to the right to decide whether we want to round up or down. So if I asked you to round to the nearest whole number and I gave you 1.1, we would look at the second one and we'd say, okay, because that's really close to 0, I should round this down. So 1.1, if I round it to the nearest whole number, is 1. Whereas if I had 1.8 and I was rounding to the nearest whole number, I'd round that up, because 1.8 is closer to 2 than it is to 1. Now what we're going to be doing is we're going to say, if I have, I'm going to round to the nearest hundredth. And so if this is the hundredth place, we need to look 1 to the right and say, does this mean that we're closer to 1.23 or that we're closer to 1.24? Should this 3 stay a 3? Or should it go up and be a 4? The rule is that if it's 0 through 4, we round down. If it's 5 through 9, we round up. And it might help you, again, to think of money. If you ended up with 1.234 and you were rounding this to the nearest cent, which would be the hundredths place, this would round down. Now, depending on if you're gaining money or spending money, would be whether you would want to round up or down, right? So we just have to have these rules so that we're consistent. So 1.234 would round down to 1.23, whereas 1.235, we would say, okay, that 5 is actually closer to making us go up instead of making us go down. So this would round to 1.24. Okay, so as you're doing these, if the issue ends up being a rounding issue, right, you can hopefully talk to your parents, siblings, whatever, and get a better idea of how to round. If the issue is still division, right, then that's a different issue entirely. So it's important to kind of realize, like, where is the issue happening here. So we're going to do 0.271 divided by 5, and we're going to basically stop when we get 3 decimal places and then round. And so we won't actually necessarily know, since we're stopping, whether this would come out evenly eventually or whether it would keep going on forever. Now, there is a trick here, like certain numbers divide evenly and certain numbers don't. Like there's a pattern kind of. So 5 always divides evenly, but we're going to follow the instructions, and instead of going until it stops, we're going to go to the thousandths place. So let's see, 5 goes into 2 no times. Put our decimal up here. And then 5 goes into 22, does that 4 times. So I'm going to subtract 20. 22 minus 20 is 2, and then drop down your next number. 5 goes into 27 5 times. So I'm going to do minus 25. And then that gives me 2 again. So I'm going to bring down my 1. And I say 5 goes into 21 4 times. And we actually don't even need to subtract this or keep going, because all we needed was to know that this was a 4 at the end. We're going to round to the nearest hundredth, so we're deciding, should this be a 5 or should it round up to 6? We decide that by looking at this 4 next to it, because 4 is closer to 0 than it is to 9. We're going to say, okay, 4 makes this round down, so it's 0.45 for our answer. Okay, let's look at D. Oh, we don't want to divide by 0.7. I'd rather divide by regular 7. So I'm going to move this and move this. So that means that I'm really doing 7 divided into 57.74. So 7 goes into 57 8 times, because 7 times 8 is 56. And then that's a 1. We bring down our 7. We put our decimal point up here so we don't forget about it later. 7 goes into 17 twice, and we get 14. So we subtract that and get 3. I've almost poorly lined this up. 7 goes into 34, almost 5 times, but it's just a little bit short of 5. So 7 times 4 is 28. So 7 goes into 60 8 times for 56. And then we get to stop, because all we needed to know was that this was an 8, because we want to decide, should this be 8.24 or should this be 8.25? And we decide based on, is this a number that's big and is close to bringing us up to the next number, or is it a number that's small so that we should just kind of, take it off and round down? Since 8 is bigger than 5, we're going to round up. So this answer is 8.25. Okay, so we've done 2 of our 4 possibilities. So the first one, we just added zeros until it ended up dividing evenly. This one, we went to 3 decimal places so that we could round to 2 decimal places. What are our other options? Well, one of our options, and this is one that I think I've talked about already because I think it's so fun. Sometimes when we divide, it goes on forever, but there's a pattern. And you're going to see that happen when you divide by 3, when you divide by 7, when you divide by 9, when you divide by 11, and probably lots of other prime numbers as well. Actually, basically, if you're dividing by a number, it should either work out evenly or it should repeat. The cases where we get something that doesn't repeat are actually special cases that don't come from us dividing by a normal number. So it may not repeat nicely, but these should repeat at some point. So our goal is to divide and add zeros until we see the pattern. And then once we see the pattern, we write our answer with a line over what's going to repeat so that somebody knows, hey, that means this repeats. All right, 0.9 into 1.21. Nah, let's do 9 into 12.1. So let's move this over here, 9 into 12.1. So 9 goes into 12 one time. Subtract 9, get 3. I actually really like the whole repeating thing. 9 goes into 31 3 times. I like it because I think it's really cool here where we're adding zeros. We go 9 into 40. That happens 4 times for 36. And then we get 4. And then we put another 0, but wait a second. So this is the part I like. When you realize, if I keep dividing by 9, I'm going to keep getting 4. It's going to keep being 36. I'm going to subtract again and get 4, and then get 40, and like it's just going to keep going. So I like that idea of like, okay, this is going to repeat. We're going to end up, if we keep going, with just 4, 4, 4, 4, 4, 4, 4, 4, 4 forever. And I suppose you could try to write that 1.34 and then like a million 4s, but even a million 4s is not actually enough 4s, by the way, because 4 goes on forever. You may have heard the word infinity before. 4 goes on for infinity, forever and ever and ever. So instead, we write 1.34 and we put a line over the 4, and then anybody who knows at least as much math as you do right now would go, oh, okay, that means that 4 actually repeats and goes on forever. And the reason we do any of this, by the way, is if we were working with these numbers in the real world and actually doing something with them, it might matter how many decimal places we have. If we want to be super accurate about something, we need more decimal places. If it's something that we don't have to be as accurate about, we don't need as many. So by figuring out that this is 1.34 repeating, we can hand this off to some engineers or physicists or rocket scientists or whatever, and we can let them decide, hey, what do I want to round to, instead of us deciding for them and maybe rounding in a way that's not helpful to them. Okay, anyway, let's do F. So we're dividing in by 11. Now, sometimes as we're dividing, like sometimes it takes a while to see the pattern that repeats, and that can be annoying. I want to sympathize with you if that is annoying to you, that it takes a while to even get it to divide evenly on some of these, or to get it to show you your pattern. I get it. Everybody goes through this. It's okay. You don't have to like it. And that's fine. It doesn't hurt my feelings. You don't have to like dividing, but you should like this video, because that's how YouTube works, is that you like the video and then more people get to watch my video because you liked my video. Right. 11 goes into 52 4 times. So I subtract 44 and get 8. Drop down my 3. 11's a little bit unpleasant to divide by, but remember that like multiples of 11, at least for a while, are really, really nice. Okay, so if you are upset that we had to divide by 11, there is a bright side. So 11 goes into 83 7 times. Make sure you put your decimal up here. So minus 77 and get 7. Okay, and then drop 4 down. 11 goes into 74 6 times. And then 74 minus 66 is 8. We're going to put a 0 here at the end. 11 goes into 80 7 times. Yes. Minus 77. We get 3. We drop down our 0. 11 goes into 30 twice. Minus 22. We get 8. And we're just going to keep going until we see a pattern. So we have 7, 6, 7, 2. So far, it looked maybe like there was going to be a pattern, but it hasn't happened yet. So I drop down my 0. 11 goes into 87 times. Okay, we've got another 7. This is a good sign. So that's 3. We add another 0 here. Get 37. 11 goes into 30 twice. Okay, I think we've got our pattern. Because think about it. If we keep adding zeros, we're going to keep switching back and forth between getting 30 and 80, 30 and 80, 30 and 80. So our repeat is that we have this 7, 2, 7, 2, and we should keep going, and it should be 7, 2, 7, 2, 7, 2, 7, 2 again. So the way we're going to write our answer is 4.7672 with a line over the 7 and the 2 to show that what's repeating is both 7 and 2. And so it just keeps going over and over and over again. 7, 2, 7, 2, 7, 2, 7, 2. So that's our answer right there. The last one, the last situation we've got, and the Math UC workbook like goes in this order, uses these instructions, and so hopefully you can kind of look at these problems that we did together and then look at the workbook and understand like what it's asking you and how to do it. This last section though, I'm going to be honest, I find annoying because I don't think it's something we do very much. It says divide to the hundredths place and write the remainder as a fraction. Very rarely do we have a decimal and a fraction together as a number. Like, it's just not a thing we do. But there is a case where I can think of that it happens, and that's at the gas station. If you've ever paid attention and it has it on the sign, you'll actually notice that like if the price of gas is $2.99, it actually is $2.99 and 9/10. And I don't know why they decided to do it that way. I don't know why they don't just say it's $3, because basically that's $3 whenever you round it. So there are situations where we might see this. I just find it super uncomfortable as a math teacher or mathematician or whatever, because I would rather just either round or write it as a repeating decimal. That's my preference. So we're going to give it a shot though. And divide to the hundredths place, and then the next thing over, the way this works is the next thing we get after we divide to the hundredths place, we're just going to take it and put it over what we're dividing by. So since on G here we're dividing by 6, we're going to end up with something over 6. So let's give this a try. 6 goes into 6 one time. So we minus 6 and get 0. We drop down our 7. 6 goes into 7 one time, minus 6, 1. 6 goes into 19 3 times, and then we subtract 18. But we've divided to the hundredth spot, 1.13. Our remainder is 1. Instead of writing R1, which is technically an option, even though, again, I think that by the time we're dividing by decimals, like, we should not need to put R1, even if it is the easiest thing to do. What we're going to do is we're going to take that 1 and put it over what we divided by, which was 6. So our answer here is going to be 1.13 and 1/6. So there you go. That's how that works. Let's try it on H. So I don't want to divide by 0.7. I want to divide by 7 because it's going to make this whole decimal thing easier. We are going to divide to the nearest hundredth. So this is going to be a bit of division. Dividing by 7 is something that repeats but takes a while to repeat, or at least the numbers I tried out takes a while to repeat. So just keep that in mind. We're gonna get something interesting here. 7 doesn't go into 2. 7 goes into 23 3 times. 7 goes into 20 twice. And you have 6 left over, so we're going to drop down this 0. 7 goes into 68 times, and we're going to do minus 56, so we get 4. So we're going to write 4 over 7 right here, and this is our answer. Now, if you're checking your answers on these and you're using your calculator, you're going to have a problem, because whenever I divide 2.3 by 0.7 on the calculator, the next digit we get after the 8, it isn't a 4, it's what you get if you do 4 divided by 7. So just keep that in mind. It'd be better if you are using Math UC to look at the solutions to see if you're right, or to, I don't know a really best way to take what you get on the calculator and turn it into this off the top of my head. So that's my thought basically is, use the solutions on these. The other ones, you can absolutely use a calculator or have your parent or sibling use a calculator to check. The problem with you doing it is once you've seen the right answer, it may feel pointless to actually try to do the problem again, or you may accidentally copy the answer instead of actually figuring it out for yourself. And what we want to do is if we get something wrong, we want to be able to learn from that. So we want to be able to go, okay, let me try it again and do it right this time. And so that's why having a parent help you is a great idea. Thanks so much for watching. This is dividing decimals again, and I think this is like, it's not that we're not going to divide decimals anymore, because we are, but this is our last, I think, here's how to divide decimals. So we are going to do other things, right? There's 9 more lessons. This is lesson 21, and there's 30 lessons. But we shouldn't have just all long division problems on the rest. Maybe they all will have long division. Maybe I'm misleading you. I don't know. I guess we'll find out together. So if you didn't like the video earlier, shame on you. Like the video now. If you're not subscribed, please subscribe. It helps me out as an aspiring YouTuber and as someone who just wants to help people learn math through the internet. So thanks so much for watching, and I'll see you in the next video.